So this is coordinate geometry part 4, and in this video we'll be discussing parallel and perpendicular gradients. So parallel and perpendicular gradients tend to become more prominent when working with the equations of straight lines, so it's important you understand what they both mean. So if line A, so as shown in the top diagram, so if line A has a gradient of m and line B is parallel to line A, then the gradient of line B must be the same and also have a gradient of m. So the term of parallel lines is the fact that both lines will, if they are parallel, will have the same gradient. So if the gradient of line A was 3, then line B would also be 3. If it was -6, then line B would also be -6. Now, if lines were perpendicular to line A, so for example here you can see that in the second diagram that we've got line A is perpendicular to B because they meet at a 90-degree angle, which I'll just emphasize with a little box there. So then what it will have is that if line A has got a gradient of m, then the gradient of line B, which would be perpendicular, will have a gradient of -1 over m. So it'd be like the negative reciprocal. So if line A had a gradient of 3, so m equals 3, then line M would have a gradient of -1 over 3. So whatever the gradient is of one line, the perpendicular line will always be the negative reciprocal of that. So what I'm going to do now is just go through some examples just to get your head around each of these. So in this particular example, we've just been asked to complete this table. So here, if it's parallel line, it's just going to have, so this first column is of the original gradient. So here a parallel line would just have the exact same gradient. So that would be -5, this would be 1/2, this would be 3/5, and this would be -3/10. Now the perpendicular gradient is going to be the negative reciprocal for that. So if this is going to be m, that's also going to be m, and this is going to be -1 over m. So the gradient of number 1, so if I just label these just to make it easier for you to understand which gradient I'm referring to. So there we go. So the gradient for question 1 is going to be -1 over 3. The gradient for 2, as it's already a minus, so it'd be -1 over -2, which then becomes +1/2. For question 3, here we're going to have -1 over 8. For question 4, it's going to be -1 over -5, and 2 minuses make a positive, so it would be 1 over 5. Now when you've got a fraction, which again is totally doable in this, so what we'll have is -1 over 1/2, which is the same, I can rewrite this as that, and so we're using the division symbol, and then using the rules of division and with fractions we flip the second fraction, so we have -1, that then becomes 2 over 1, and it turns to a times, giving us -2. So the gradient for the perpendicular line when a gradient is 1/2 would be -2. And likewise, now a general rule of thumb is that basically when you have got a fractional gradient and you want to work out the perpendicular gradient, just simply flip the fraction and change the sign. So here we've got a gradient of 3/5. So if I do the negative reciprocal of that, that becomes -1 divided by 3 over 5. And again, I could write that as 1. So here we've got -1 over 1 times 5 over 3, which then becomes, and again, -5 over 3. Now a much quicker way of, rather than writing all of this out, is just to remember that rule of when you have got a fraction and you want to do the negative reciprocal of it, just simply flip it and change the sign. So this would be 5 over 3, and it'll be a minus. And likewise with number 7, we flip the fraction so it becomes 10 over 3, and we change the sign so it turns into positive. So hopefully that makes a little bit more sense with regards to working with parallel and perpendicular gradients or finding such things. And like I said, this becomes a lot more prominent when you're working out the equation of lines or working with right angles or in triangles and proof and things regarding parallel. If you have any other questions or would like a worksheet on this, feel free to drop an email at 162 at maths. Let me repeat that again, 162maths@gmail.com.